All right, hello. We are going to go run through the Chapter 5 homework practice with specific gravity and density. So the first thing is question 1 and question 2 are from the lecture. So unless you want a review, just skip those two. The rest of them are new homework problems, at least most of them, as I noticed. So I'm just going to go through just 1 and 2 just to show you, because I'm guessing that some people are probably watching this later. So your density is grams per volume. So our grams are 203 per 250 ml. Make sure to label it. So that is that. All right. A piece of copper metal weighs 53.6 grams, 6 milliliters, calculates density. All right. All right, here's the new stuff. So if a 150 milliliter, I think it's 150 milliliters of a sorbitol solution weighs 170 grams, what is its specific gravity? So it would be 150 mLs of water would be 150 grams. So take 170 and divide it by 150. And because 150 mLs of water would equal 150 grams, these can both be grams, and then they cancel out, and that gives you your specific gravity. So and specific gravity does not have a unit. All right, a liter of cough syrup weighs 1,285 grams. What is its specific gravity? So the liter would be the same as a liter of water, but the water would be 1,000 grams. So you take 285 grams divided by 1,000 grams. That is 1.285. And then there's no units because the units cancel out. All right, 500 milliliters of a ferric chloride solution weighs 650 grams. What is its specific gravity? So this is 650 grams. You take the equivalent of water would be 500 grams. So these cancel out. And then 1.3. Yep, that is right. I have the answers off to the side so I'm not getting lost. All right, here's one of our little tiny bit more complicated questions. So if a 2-ounce fluid ounce of glycerol weighs 74.1 grams, what is its specific gravity? So we have 1 ounce is, according to Google, 29.5735 milliliters. So then we want to, because we have 2, so we have 2 ounce 1 ounce 29.5735 ml. And then we want to, that is the, so for every single 1 ml H2O. That is the same as 1 gram H2O. So these cancel out, these cancel out, and then you just have grams of H2O. So that would $59,147. All right, 59,147 grams H2O. Then you have your 74.1 grams glycerol over your 59.147 grams H2O. And because these are, well, your specific gravity is just a ratio to water. So that's your ratio to water. So 74.1 divided by that number, 1.25. And because the units cancel out, find that is the answer. All right, picnometer weighs 21.6 filled with water. It weighs 46.71 filled with another liquid. It weighs 43.28. Calculate the specific gravity of the liquid. So we have the liquid and the picnometer. I believe that's how you pronounce it. And then you got to find the difference. And this is the liquid that we're trying to find. Just trying to label it so I know that. And then 46.71 grams minus the 21.62 grams. Actually, I should probably relabel this so this is a little bit easier to tell what we're doing. Okay, so this is the liquid and picnometer. This is just the picnometer. This is also just the picnometer. This is H2O plus the picometer. So we are finding just the weights of these. So $21.66 grams of our liquid. And then the reason I have this set up is because eventually you want to find the ratio between these two. So I have it set up just so. 6.71 minus 21.62, 2509. And that is our H2O. And then these two cancel out, and you find the ratio of the liquid to the water. That is 0.863. And make sure you put the 0 in front so that, and that is the specific gravity of the liquid to water. And that's right. Okay. Yep. All right. What is the weight in kilograms of 5 liters of sulfuric acid with a specific gravity of 1.84? Number 11. Okay. So, because we're going from liters to kilograms, we don't necessarily have to actually change. So we just do 5 liters. And the ratio is 84 over 1, which is the same. And then you find that multiply 5 times 1.84, 9.2. 9.2 kilograms. Okay. All right, what is the weight in pounds of 5 pints of nitric acid? So the question does not give you the specific gravity of nitric acid, which I had to look up, which is 1.42 as the specific gravity of nitric acid. So that's what we need to have in order to solve this question. And also, 1 pint is equal to 473.176 milliliters according to Google. If you're going to do the problem, you normally just don't have that. So we're going to just go and use 473. So we have 5 pints. So we want to find the volume of this. So the 5 pints and is 473 milliliters for every 1 pint. And these cancel out. And then want to do the specific gravity, and that is for every 1, it is 1.42. Yeah. Okay. So then we find that this, and that this is grams. This is milliliters. This should cancel out because the 1-to-1 ratio on water. So don't get too confused. So this is, let me see, all right, 5 times 473 times 1.42 is equal to 3,358.3 grams of nitric acid. And then we have to find the weight in pounds. So this is, so so we're going to convert this to kilograms, which is 3.3583 kilograms. So 33583 kilograms, and for every kilogram, there are 2.2 pounds. So 2.2 pounds, 1 kilogram. That eliminates that unit. So then, pulling up the calculator. Times 2.2 equals 7388.6, which is close to the answer. So that is, oh, no, it would be there. Whoops, would not be there because we're doing it. So that would be millipounds, I think. So yeah. So, all right. So that's how many pounds. All right. What is the weight in kilograms of 1 gallon of sorbitol solution having a specific gravity of 1.285? So earlier we said the 1 pint equals 473, and then there are 8 pints to 1 gallon. So we just need to multiply that by 8 to get our gallon conversion. 3784. 3784 milliliters for a gallon. Okay, and then so we just take our milliliters and which is 3784 milliliters, and then we multiply it by the specific gravity. Grams. All right. 4,862.4, and this is in grams, and they want it in kilograms. So our kilograms would be 4.8624 kilograms. And then, all right, what is the volume in milliliters of 1 pound of benzoate having a specific gravity of 1.12? So, so we take 1 pound and we would convert it to the metric from our imperial units, and then that would give us the kilograms. So then we could just straight up convert this. So this is not a 1-to-1. So this will give us, this will actually kilograms to liters. Aha. So they would have the same ratio whether or not you volumized it up. So 1 divided by 2.2, and then divide that by 1.12, and that is 0.4058 liters. So the milliliters would be 405.8 milliliters. And then I believe this is the last one. This is volume in milliliters of 1 kilogram sulfuric acid with specific gravity of 1.83. So and convert this to and then yeah, so for every so for every 1.83 grams there's 1 milliliter. Yep, and that gives us 546 point, I think it was 45 milliliters. Okay, and that is it for the practice problems. They're all pretty straightforward. The only thing is remembering the pints and ounces and pounds conversion, because that will be something that they will not give you on the test. Should give you specific gravity because you don't normally have that. But that is it. That is how you do that.